Hello everybody, my name is Junfeng Yang. Today I'm going to introduce a key concept of fluid mechanics. This key concept is so-called the Navier-Stokes equation. First, let's understand what's the Navier-Stokes equation. The definition of this NS equation is that a statement of the balance of momentum on a viscous fluid. So this equation is named after two famous scientists, Claude Louis Navier and George Gabriel Stokes. This equation was used to describe the motion of fluids. This balanced equation arises from applying Newton's second law to fluid motion, together with the assumption that the stress in the fluid is the sum of the diffusion viscous term and the pressure term. There is an example here showing how the NS equation looks like for the incompressible fluid. As you can see, in the equation of the left-hand side, there are two terms called variation term and the convection term. On these two terms is normally called so-called inertial force. On the right-hand side equation, there are three terms. The first one is called pressure force term. The second term is called diffusion term, is also called viscous force. The last term on the right-hand side is so-called the external force term. Normally is represented by the gravity and the surface tension force. So by solving this partially differential equation for NS equation, we can get the velocity field and the pressure field. And also by solving other governing equation, we can get the temperature field. So this equation is very useful because they describe the physics of many phenomena of scientific and engineering interests. They may be used to model the weather, oceans currents, water flow in the pipe, and airflow around the wing. So there's one example below this slide, is that by solving the NS equation, we can get a velocity field for the flow past the cylinder obtained by solving 2D incompressible NS equation. And so the NS equations are strictly a statement of balance of momentum. To fully describe the fluid flow, more information is needed. How much depends on the assumption made. This additional information may include the boundary data, conservation of mass, balance of energy, and equation of state. I will introduce other equations later on. 你看行不行？